Hello calculus and welcome to 8.4. This is improper integrals, which are integrals that go to infinity, or they start at infinity, or they have it on both ends. So let's have some fun with this. Alright, so we're going to evaluate improper integrals. First thing is it has to be able to be evaluated. Alright, so let's start with some of our notation. Right here, when we go from a to infinity, we're going to let the infinity become a b, and they're going to do the limit as b approaches infinity of the integral. So we'll integrate it and then plug in our limit as we go. The same will go with negative infinity. We'll go to a b on the top, and we'll replace the infinity with an a or whatever numbers we want. Here, when we have negative infinity to infinity, we'll have to break this into sections, so like c to c. The other thing that has to happen is when we're doing infinity, so like here, we're going to start at a number and go to infinity. So this is like our first one right here. It has to approach 0 down here, because if it is not converging, if it's diverging, there's no limit and we cannot find it. So let's do our first test here and see if we have limits. So I want to go from 1 to infinity of 1 over x. So now remember that x is x to the negative 1. We're going to let the infinity, and I just chose a letter b. So we're going from 1 to b of 1 over x dx. We have to do the integral of that, or the antiderivative, which gives us the natural log of x from 1 to b. We'll plug in our b, so it's the natural log of b minus the natural log of 1. Well, the natural log of b, natural log of 1 is 0, which gives us the natural log of b. So what happens as b approaches infinity? Well, we know our natural log graph, if you think about this, goes like so, correct? Well, as b approaches infinity, so it's going in this direction, it continually gets larger, so it is diverging. Since it is diverging, there is no limit to this function. All right, now let's do a converging one. We're going to go from negative infinity to negative 2 of 1 over x squared. Again, we let our infinity be a variable, doesn't matter which one. We go from a to negative 2 now. This is x to the negative 2. So our antiderivative is negative 1 times x to the negative first, which gives us here. We're going to go from a to negative 2. So we'll plug in the negative 2 first, and we get a half. Plug in an a. We're subtracting, right? And we got minus a negative a, which gives us a positive 1 over a. Well, now, as a approaches infinity, 1/2 becomes 1/2, but 1 over a approaches 0, because as the denominator gets big, the fraction gets small, and this approaches 0, leaving us with 1/2. So this converges because we actually found an answer. We can find this limit. All right, I want to know if the limit exists or not, so pause and try yours. So your first step, I just am going to let infinity be b. So the limit as b approaches infinity of 8 to b of, and I'm going to write this as a negative exponent. You're going to do your antiderivative. So the limit as b approaches infinity of negative 3/2. Remember, you add 1 and divide it to x to the 2/3 power. And we are going to go from 8 to b. Well, when we plug this in, this is negative 3/2 x to the 2, or sorry, b, let's see if I can write better, b to the 2/3 power minus a negative 3/2, 8 to the 2/3 power, or plus a positive. Well, now, as we put in infinity for b, that's going to continually get larger because it's the 2/3 of infinity. Since it's continually getting bigger, this guy diverges. No limit. It does not approach 0. That writing is terrible. Okay, let's try this one. So now we're going to let the limit. I'm going to do b again. You can use any letter you want. So this is going to go 8 to b. And I'm going to write this as negative 4/3 dx. Do your antiderivative as b approaches infinity of add your 1 and divide. So this is negative 3 x to the negative 1/3, all from 8 to b. So this is negative 3 over b to the 1/3 power minus negative 3 over 8 to the 1/3 power. While as b approaches infinity, this thing gets smaller and smaller, so this approaches 0. So this is equal to 0 minus a negative is plus 3. Cube root of 8 is 2. So our answer is 3/2. So this guy converges. This should not say divergent. This converges. And the answer is 3/2. So we're happy. We can do that one. Okay, now let's look at negative infinity to positive infinity. This one's a little different. You have to break it up. I almost always use 0 just because it's easier and it's easy to calculate, but you can choose any number you want. It does not have to be 0. So we're going to go from negative infinity to 0, then from 0 to infinity. Whatever number you choose has to be here and here. So now we do the first one. I let b equal my limit. So it goes from b to 0. We do the antiderivative. So we have 4 over negative 3 e to the negative 3x from b, or 0 to b. Plug in our 0, plug in our b. Well, the first one, well, e to the 0 is 1. So this becomes negative 4/3. But as this gets large, this whole denominator gets large, and this continually gets bigger. Now remember, this is negative infinity. So this really moves it to the top here. So this really e3 to the positive infinity, and that's why this is infinity and not 0. Therefore, it diverges and does not exist. If one does not exist, you do not need to try the other, and we are finished. It's only when they both exist that you have to continually go. All right, it's your turn. So I'm going to use 0 again. So we're going to break this up. We're going to go negative infinity to 0, 5e to the negative 2x dx, plus 0 to infinity of 5e to the negative 2x dx. Okay, we're going to come down here. We're going to have my limit. I'm going to use a this time just for fun. Negative infinity. So now we're going to go from a to 0. Of 5e to the negative 2x dx. Let's do our antiderivative. So this is 5e to the negative 2x all over the negative 2, all from a to 0. As, I forgot to write this over here, the limit as a approaches negative infinity. So we plug in 0, and when we plug in 0, e to the 0 is 1, so we have a 5 over negative 2, minus, now we're going to plug in a, so this is 5e to the negative 2x all over negative 2, making that positive. But now a approaches negative infinity. Well, since this is negative infinity here, this is going to move to the bottom. 5, oh, I'm sorry, negative times a negative leaves it in the top. E to the 2 infinity all over 2. So that means this is continuing to get large, which means this is approaching infinity. So we have negative 5/2 plus infinity diverges, no limit. Therefore, there's no need to test the other side. All right, I hope you did well. Good luck on your homework. Remember to post questions on the discussion board. Have a great day.